Okay, Wildcats, today we're looking at Friday, September 21st, solving absolute value inequalities, and that's going to be on page 15. If you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at your notes. Solving absolute value inequalities on page 15. Conjunctions, connected and. A conjunction is a compound statement formed by joining two statements with the connector and. So the absolute value of less than, the solution is x is greater than a number and less than a number. The absolute value of less than or equal to a number, the solution is x is greater than or equal to a number and less than or equal to a number. So the key is when you see the less than symbol, you know it's and. The solution can also be no solution, empty set. Disjunction or disconnected or. Disjunction is a compound statement formed by joining two statements with a connector or. So you know absolute value greater than if x is greater than a number or x is less than a number. When you have the absolute value greater than or equal to a number, the solution is x is greater than or equal to a number or less than or equal to a number. The key is if you see greater than, you know it's an or statement. The solution could also be all real numbers. Solving absolute value inequality steps. Step 1, isolate the absolute value. Step 2, apply the absolute value definition. Step 3, solve for the variable. Step 4, sketch the solution on the number line. If you would, update your notes. All right, now your notes are updated. Let's take a look at the examples. All right, example 1. Now, before you do example 1 and example 2, take the time to add a x and y axis and a couple lines to do your work, as I've done on the page. All right, I assume now you've updated that. You have your x and y axis and some lines to do your work. So step 1 says isolate the absolute value. The absolute value is isolated. Apply the absolute value definition. So we have p plus 4 equals 8. We're going to ignore the inequality. We're just going to use the equal signs. And p plus 4 equals negative 8. Okay. Step 3, solve for the variable. So we subtract 4 from both sides. So p equals 4. And we subtract 4 from both sides. So p equals negative 12. Okay. Now step 4, sketch the solution on the number line. So we're going to graph the left side and the right side. So to graph the left side, we see the plus 4 means we shift 4 units to the left. So you can just approximate. Just has to. Okay. Now the right side is 8. So we have a horizontal line at 8. Now, because we know the p-values are 4, negative 12, we know that it intersects when p is 4 and when p is negative 12. Now, to understand the solution, it says less than. So you're looking for when the graph is less than. So it looks like this part of the graph and this part of the graph is less than 8. These two pieces, okay, these two pieces are greater than. Let me add some more close so you can see that these part is where it's less. So the solution is here between negative 12 and 4, which makes sense because this is a less than, and we know from our notes that a less than equal to is an and statement. And we can see that our answer is between. So to graph our solution, we know that we have closed circle at negative 12 and a closed circle at 4. Should have put 0 first. And we know we're shading between negative 12 and 4. Okay. So now let's take a look at example 2. All right. So step one, isolate the absolute value. So we add 2 to both sides. So we have the absolute value of x is greater than 2. Step two, apply the absolute value definition. So we know that x equals positive 2. And again, we're ignoring the inequality. We're just trying to find the solution values, and x equals negative 2. Step four, sketch the solution on the number line. So to graph this, we know that we're not looking at this anymore. We're looking at this, that this is the parent function absolute value. So we know that this is here. Okay. And then we're going to graph a horizontal line at 2. And we know that the intersection points are at positive 2 and negative 2. All right. So now we're looking for when it's greater. Well, we know it's greater, meaning above the line here and here. So we can tell this is an or statement because it's this or that, which we knew because this was a greater than, so this is an or statement. Okay. Now I forgot to do a part on example 2, or example 1 that I'll do on example 2, then I'll go back and do example 1. But we do the graph first, so we know that at 0, and I'm going to put the numbers above the line because there's all that marking there. So then 0, we know 2, and negative 2. Now, because there's no line underneath, we know this is an open circle here and here. And we know that, and basically, this should match the graph. So we know that it's greater to the left of negative 2, so we shade to the left of negative 2. We know it's greater to the right of 2, so we shade to the greater to the right of 2. Now, what I forgot to do in example 1 is this. Is I forgot to write the solution in inequality notation. Okay, so we know that x is less than negative 2 or x is greater than 2. All right, so let me go back here. So we know that in example 1 that the solution should look like that. So the inequality symbols both go in this direction. We know x is, in this case, p, and we know that p is between negative 12 and 4. All right, so now I've omitted examples 3 and 4. So if you would just omit it or mark it out, and let's move on to example 5. All right, example 5. Step 1, isolate the absolute value. So we're going to subtract 8 from both sides. So the absolute value of x minus 4 is less than negative 3. Now, this negative on the right side concerns me, okay? So I want to, before I start looking at the solving, I want to actually see what the graph looks like. So we're going to graph that. So that minus 4 means we move the graph to the right 4. And again, you're just approximating. All right, and then we have a horizontal line at negative 3. Now, it says that it's less than, so we shade below. So we can see that this will never overlap any of it, so we can say that this is no solution. And then the graph would just be blank graph. All right, example number 6. All right, so first thing we do is isolate the absolute value. So we subtract 1 from both sides. So you get absolute value of x plus 3 greater than or equal to negative 3. And again, that negative on the right side worries me. So I want to graph first to see what the graph looks like. Okay, so here x plus 3 means we shift to the left 3. All right. So now we have a horizontal line at -3. Okay. But it's greater than, so we shade above. Now you'll see here that everything is included. So the solution is all real numbers. So the number line, you would shade everything. Now, I know this is a difficult concept to understand, but if you understood it, then start working on the assignment. If you had some trouble with it, just know that you have options. You can go over it with me in the teacher list station, or you can work with a partner in a small group station. Either way, with that, have a wonderful Wildcat day.